Now, continuing on with graphing, there's a special kind of graph that we want to pay a little bit more attention to, and that's the graph of a circle. So what is a circle? A circle is all points equidistant from a fixed point. What in the world does that mean? It means that if you take a piece of string, this provides the equidistant, and anchor it at a certain fixed point, this is the fixed point, and then allow it to trace all the points that are that distant from your center point, you get a circle. Now obviously, your arm kind of gets in the way when you're doing this, but you should have all seen something like this when you worked with compasses as a child. The standard form of the equation of a circle is x minus h squared plus y minus k squared equals r squared, where the center is the point h, k, its coordinates here and here, and the radius is r. Now, you should be saying in your head, this looks awfully familiar, and it is, because all it is the Pythagorean theorem rewritten, or the distance formula rewritten. You'll notice that the Pythagorean theorem is going to show up a lot in this class. In fact, I think it's the most important theorem in all of mathematics. And we see it over and over and over again in different forms. Now, let's do some problems. I would like to find the equation of a circle whose center is 7, -1, and whose radius is 3. Well, since I have the standard form, this simply involves plugging them in, and I'm done. So it's x minus the 7 squared plus y minus -1, or y plus 1 squared, equals our radius squared, which is 9. And there's nothing to do after that. I'm done. It's a little bit harder if instead of giving you the center and radius, they tell you the center and a point on the circle. So I need the radius, but what do I know? I know that the radius is the distance from the center to any point on the circle. So first, I'm going to find radius using the distance formula. So this becomes 4 squared, 16, 3 squared is 9, 16 and 9 is 25, square root of 25 gives me a radius of 5. And now I can literally plug these in to the formula for a circle. Now, what is a little bit harder is when they give you an equation of a circle and ask you to provide the center and radius. Because if you notice, this equation looks nothing like this equation. And until it looks like this, we can't tell what the center and radius are. So, we have a trick though, already for how to find the center and radius of this circle. I'm going to complete the square and turn it into this form. Okay, now, I'm going to actually complete the square twice in one problem. Once on the parts with x, and once on the parts with y. So my first step is to get everything with x together and leave a little room. Then get everything with y together and leave a little room. And then put anything without an x or a y over to the right-hand side, as is usual when we complete the square. Now, I need d. If you remember, to find d, I took the middle number, the number on x, and divided it by 2. So this d is -1. Over here, you take the 6 and divide it by 2, and you get 3. Okay, so for the first completing the square, I want to add d squared, which is I want to add 1 to both sides of the equation. For the second one, I want to add d squared, meaning I want to add 9 to both sides of the equation. Okay, now, as is usual, whenever we complete the square, this factors is x plus d, which in this case is x minus 1, quantity squared. This one, with the exception of the fact that it's y instead of x, does the same thing. Y plus d, quantity squared. And over here, I just have to add up what I have. 9 plus 1 is 10, minus 6 is 4. So now the equation is in standard form. So the center is 1, -3, and the radius is 2. And again, I was able to put it into standard form by completing the square on both the x and the y.